Hey, y'all. Thanks for tuning in and welcome to the first episode of Immune to Ignorance Women in Science Speak Out. My name is Dr. Jamie.
And I'm Dr. Olivia. I had been bothering Jamie for quite some time, like a time period of years, to do some sort of science related content, podcast, something like that relating to biomedical research. However, it's really the current events happening right now in our country that have led us to actually take steps to create this project. This was born of us witnessing that there was a significant lack of knowledge surrounding the funding freeze and how the indiscriminate firing of scientists and slashing of research funds at the National Institutes of Health will destroy biomedical research in the United States and lead to significant and profound human suffering. So this makes sense. This information is not really readily available. We were really hoping to create content that's easy to share and easy for you to like share with your friends and family and everything you need to know about this in kind of one place.
Yeah, and really make it something that I feel like that it's been covered in the media, but you just hear like these snippets of like, oh, they're cutting funding, right? But like, what does that actually mean? And that's like kind of what we want to talk about to kind of shed some light on how the policies that have been implemented by this administration are actually affecting people on the ground. So both me and Olivia are scientists. We're both immunologists, and I just recently got out working in academia. Livy, just got out a couple years ago, and we really feel like uh, what's happening with the NIH and the funding and the biomedical research is something that needs to be understood by the public more readily than it is right now. So hopefully we
I,
can bring some light to
I,
that.
I think a big part of the problem is that people don't quite know what it actually is to be a scientist, like the job description, but also how does one begin to be a scientist? What's the infrastructure by which scientists are created and within which they do their work? So all of that has to do with the National Institutes of Health, has to do with funding, grants, grant writing. And that's kind of what we want to cover in this podcast. And this is so important because we know that, just like us, many of you have had a loved one or maybe yourself that was diagnosed with something really terrifying, something really painful. It could be cancer, autoimmune disease. It could have had a stroke, neurodegenerative diseases such as Alzheimer's. We all have parents, friends, children, brothers and sisters, aunts and uncles, etc., that go through this. And I think that it's important for us to communicate that the goal of scientific research is to help. We really want to help you. We really want to help your family. I became a scientist because my stepfather was diagnosed with multiple sclerosis when I was 7 years old. And at the time, not much was known about the pathogenesis, which is how we talk about how a disease develops and how it goes through its phases of MS. Not much was known about what causes it. There were not any good therapeutics at that time, and that really put me on my journey. At the time, I was a little kid. I was in second grade, so I was like, I'm going to be a doctor. I'm going to be a medical doctor, which is what we call them to differentiate them from us, the
The
research doctors.
clinicians, yeah.
hmm And when it wasn't until I was in my undergrad, a couple years into my bachelor's of science at Michigan State University in cellular physiology, where I was introduced to the concept of biomedical research, to designing an experiment and analyzing the resulting data and drawing conclusions, and how you can use this to create new therapeutics and new knowledge that didn't exist before,
Mm.
that could actually meaningfully help people.
Yeah, and I think
And
I think like, and I'll add to that to say that I got into biomedical research in undergrad. I got working in a research lab that was doing gene therapy. And this was so powerful to me to understand that we could actually take an individual that was born missing a gene, and through biomedical research and putting a lot of heads together and working towards this, we could actually restore gene expression of the missing gene by developing this therapy. And that was bringing a treatment to a family that otherwise had no option for their children. Some of these kids were going to die if they did not get this type of treatment. And now I've seen that come all the way full circle to the clinic. And so I have a really strong love and attachment to how powerful the work that we do in the lab, and how the NIH funds work like this, to advance science and bring treatments to patients that otherwise didn't have any other choice.
And I want it to be known that like our stories are not unique. I think throughout my decade of academic research, I encountered a great many scientists that were motivated by wanting to help. I could say that if you have a chronic illness or someone in your family, like I want to help you. I went into what I did in hopes of helping you.
Mm-hmm.
No matter what your background is, no matter what your beliefs are. And
And
I can be pretty intense about my beliefs, but if you are sick, I would like to help you. And I think that's something that we have in common as scientists. And by the time I was doing all of this, I decided I was going to get a PhD. I applied to grad school. I got into the University of Florida where I met this one and moved to Florida and began, my PhD. By that time, my stepfather was primary progressive and his quality of life was already terrible. He passed about 3 years ago after a really long fight with MS. And I knew it was too late for him and my family, but that's not really what it's about. It's about everyone. It's about reducing suffering in the future. And it's about honoring his memory for me, honestly. So yeah, we're not unique. People don't go into this job to make money or
yeah,
have job
absolutely not.
security or be
Yeah.
famous.
No, no. It's that.
We get none of that. Nobody knows who we are. People don't
No.
know who the most famous scientists alive are right now.
Yeah.
Very few even that are dead.
Mm-hmm. It can
uh,
it can in that way like be a little bit like a thankless job. I mean, like in so many instances too, like, as a scientist, you're not like sitting there at the bench like going from like nothing to some kind of breakthrough therapy, right? Like we're all just like contributing one little baby bit to the bigger picture. And but you have to like find like some joy and you find purpose in adding that one little piece, because when we all add those pieces together, that's when we get a breakthrough therapy, and it's what everybody individually does collectively that actually takes us there.
I feel like there's this narrative that we are motivated by things that we're not. And this includes other scientists I've met. But at the base of it, you become a biomedical researcher to reduce human suffering and to approach that problem at the source. And yeah, so I just wanted to say that and express that we're not trying to talk down to you. We just would really like you to understand what's happening, that it's actually going to affect people that are sick. It's going to affect ongoing clinical trials and ones that are scheduled to start or supposed to start over the next few years, and why this matters. So, just how scientific research works, the infrastructure of it.
Yeah,
Because
and how and how the recent changes that have been made from the Trump administration, and how those are actually affecting the scientific research. So, if maybe you voted for Donald Trump, maybe you didn't, but um, you know, I think that a lot of people maybe don't know that they voted for reducing medical research. And I think that's another big reason why we're here, is to talk about that and talk about what the real impacts of the funding freezes, the banned words of the NSF, and also the cuts to the indirect costs at the NIH.
And I don't believe that one like major point is that every single scientist that exists, whether they work at in biopharma or biotech, they start their own company to stimulate the economy. If you're a very like money motivated type of person that likes to think of things that way, we have a lot of those in this country. Every single person with a doctorate started in academia.
Yeah.
You have to have a mentor who is a PhD, and they're called the principal investigator. They're your boss. And you have
Mm-hmm.
to have a committee of other principal investigators that are established scientists, and they guide your development. At the end, you have created new knowledge, and then you have to defend that,
Mm-hmm.
and then you have to write your dissertation, and that's how we begin. So to unilaterally and widely slash this funding is just reducing the amount of those positions. It's basically to eradicate and reduce scientists at their very beginning. So this won't be too pretty at first. It won't be too fancy. Scientific content creation I thought would be cool. I mean, people express interest to me all the time, but it's not like a life goal that we really had. We don't, if we look awkward as hell, I mean, we're not used to staring into a camera and talking like this. I share some artistic stuff on my social media, but it's not like, hey guys, it's not really been my vibe. I work full time as a scientific consultant at the moment, basically, and Jamie's a full time bench scientist. So it's a lot to do this also on our off time, but we just think that it's really important to do. And
Yeah.
hopefully we will just improve everything over time. We're on a roll right now. We just want to get it going. We want to get something out. So
Yeah, things are happening so fast, and and I think that like both Olivia and I are, have thought about this idea, and have started to feel like, that we have a voice, and we have a voice, and we have perspective on this subject. And I feel a little bit like I have a duty to at least share my perspective, to a greater audience, especially one that, you know isn't familiar with this process, isn't familiar with biomedical research, doesn't know what it means when they NIH is cutting funds. And I just think it's so important that, uh, we're able to actually talk about this in a way. And what we want to do is try to reach an audience, that maybe is curious about what the NIH cuts mean, or just wants to know more information about how that's really affecting people on the ground.
Yep, absolutely. And you got to be bad at something to be good at it. So please bear with us.
Yeah, we're doing our best out here.
But
Okay, wait.
I guess we already talked about how if you're like a big lab boss, you have an R01 funded, but it goes down the list of people. So if you're a PhD student, you can apply for an F award. I got my F award funded, and it was one of the crowning achievements of my PhD.
Mhm.
And similar to a publication, it's basically like the currency that you use to move forward in your career.
Mhm.
If you are a postdoctoral fellow researcher, which we both did as well,
Yeah.
then you can seek to get on training grants. But your goal is to get a K award,
Mhm.
also from the NIH. And this K award allows you to
Yeah.
move forward with your career.
Yeah. So there's all these different series of awards, and at the PhD level, you can apply for F awards. At the postdoc level, you can apply for, like she said, the T award, which is a training grant, or a K series, and the K series is a transitional grant. So this would be something that you would work towards in your postdoc. That, like she said, we both did. And what that award would do is it would allow you to work on a project for 2 years and then transition into a faculty position, so you can actually show up at the door at a university and say, hey, I already have funding. And then you would have a period of 2 years or so to essentially secure our funding, which is what the big grant is. So if I have a faculty position, I come in with a K, then I'm going to need to get R01 funding, or some kind of R funding, in order for me to actually establish my own lab and have my own research program.
So when you write and compile and submit your 100-page document
Yeah, it's a
that
long
is an
document.
NIH grant, which requires a village of people, which we will talk about later, that help
Mhm.
you with this process, with the actual submission,
Yeah.
because you're in the lab, right?
Mhm.
Like you're in the lab, and you need some like administrative people to help you with that.
Yeah, to write budgets and to figure out, yeah, all the facilities and that sort of thing.
They know exactly what you need, how to submit it in the different places, like
Mhm.
make sure it's correctly submitted and not discussed over complete BS.
Yeah, the bureaucracy, if you will.
Hmm.
Yeah, scientists don't love bureaucracy. I don't think anyone does.
Why do we need to be experts in that?
Right.
Like, there's people that's their job,
Right, and
So
they're tremendously helpful, going through this process. So yeah, so you prepare this huge document, right? And so the way this process works is, so when you submit a grant to the NIH, and we'll talk about the R grant, for instance. So when you submit a grant to the NIH, it's this long document, and basically it's going to get reviewed by a panel of scientists that are already R01 funded. Okay, so if you receive funding on an R01, then you are required to also participate in the review process. And this is called the study
study
section.
section.
Yeah, so you sit on a study section, and basically what you're going to do is you're going to start, reading through these grants, and essentially somewhere in the range of 90% of them are not even going to get reviewed. You get a score of not discussed, okay? It's a terrible
Do
grade.
not pass
Yeah,
go. Do not collect
no.
$200. Congrats on your months of
Right.
writing
Yeah,
and
you did. Yeah,
preliminary
yeah,
data,
you just did
but
all this
good day,
work.
sir.
Yeah,
Like, basically
exactly.
is like that. Yeah.
Yeah, thanks for nothing. Yeah. So you work really hard on this thing, and they toss them in the middle in a pile on the floor. Okay, but for the lucky individuals that, are in this top 10%, roughly, that will get discussed, what they're going to do is they're going to actually read through the grant, and they're going to score the grants. And then, even if your grant gets scored, they're going to take like an average score of all of the grants and establish what's called a pay line. And your score, even if it gets scored, your score still has to be above that pay line in order for you to get money. Okay, so even if it gets scored, it still might not get funded. So we have this rigorous system to establish who's going to get paid for their research and who's not. And if you
And
are
not just paid for, but like each one of the
to
mice I
do
worked
it,
with was like $50.
yeah, I mean,
And
this
there
is,
might be 150 in an
yeah,
aim of my experiment. Like you need to obtain money.
yeah,
Like
yeah,
money needs to be obtained to buy the reagents, to order, to do the things.
yeah, yeah.
And I
It's not
want
cheap.
to note that we personally knew a PI who just couldn't get an answer from the NIH about her study section at the beginning of this freeze, when there was no communication.
Oh yeah, 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 yeah. So yeah, at the beginning of the freeze, there was a date that of a grant submission, and yeah, she wasn't even receiving her grants. So that means that people that submitted their grants, they weren't being reviewed. And this was in the period of chaos. I do think that they eventually released the grants and they eventually had them, but this is the type of chaos that these policies have created.
The When travel is not allowed, one thing I don't think a lot of people understand is the absolute like integral importance of conferences to the development of a young scientist and to an established scientist. You absolutely must travel. You must present your work to other people that work in your field. We continuously practice and give talks in order to be able to communicate our work, because without each other we have nothing. We have to all collaborate together to move the field forward, and it's such a major part. So PhD students having their conferences just canceled. I mean, people didn't go to meetings
Mhm.
during this time
We
period.
cannot overstate how important these conferences are, and let it be known that this is not like some kind of vacation for a scientist. These conferences are extremely important for us to be able to network with people who work in our field, to build collaborations, to move the science forward, and also really like just to make like to stay up to date on what other people in the field are doing and making sure that the work that we are doing in our little bubble of our research lab is actually relevant to the greater field.
Because a lot of pre-publication research is presented at conferences.
Mm-hmm.
It could take years for you to get a paper done, written, accepted, and put into a journal.
Mm-hmm.
But you are seeing exactly where the field is at that moment in time when you go to a conference. And that is so entirely important. We do rotation talks during our rotations. We do lab meeting presentations. All this is practice
Yeah.
to go to conferences and to rub elbows with other researchers and really like learn from each other and be able to move the field forward.
Right.
I almost moved to Belgium after I went to a conference in London because I met our collaborating lab, and me and the graduate student, we wanted to work together. We wanted to finish our PhDs together, and it almost worked out. Not quite, because of literally the first Trump administration.
Yeah.
But, then
What are you
COVID
gonna do?
happened shortly after I would have gone. So the universe spared me that one. But
Yeah, but that all that is to say is that by blocking people from going to these conferences, and a lot of these conferences are only done annually, and it may not seem like that. Like, so if like, it may not seem like that long of a time for 1 year, but that's a huge amount of time to be behind on your research because you didn't go to the meeting or the conference that so that you could figure out whether or not a research trajectory that you had decided to take was maybe already found out by somebody else to be bunk, or is already being done by somebody that's way ahead of you, so you don't want to waste your time. And the next time that you're going to get the opportunity to be in the presence of and to hear from these other researchers that are doing very similar work to what you're doing is going to be the next year because you missed this conference.
there's also hiring was completely paused. So there was actually an email from the NIH's Office of Human Resources. They rescinded existing job offers to anyone whose start date was slated for 8 February or later, and also pulled down currently posted job vacancies on USA Jobs. And I think all of us right now, as people are just getting like unilaterally fired and wiped out, and just how bad the economy is and the job market is, I think most of us can relate to the nightmare that would be having a job offer rescinded
Mm-hmm.
for no reason, for no fault of your own. You have finally gotten this life wrapped. You're a
Yeah.
scientist and you have
At,
impressed people, and
at
they
the
have decided
NIH. At the
we
NIH.
want you, and we have given you an offer, and here you go, and it's rescinded for this.
Mm-hmm.
I mean, I can't.
Yeah.
It's a
And
nightmare.
it's sending a message, that the people that get hired at the NIH, like this is going to be like, I mean, that's like a dream job, right? Like that's like you actually like you made it, as a researcher to get to go work at a world renowned research institute, and they are telling you that they don't want you, and they are telling you that we're not taking the top of the line scientists anymore, and we don't want the new people coming in, right? So I don't know what that means to the next generation or how that's going to affect research in the future, but that is the state of things. That the hiring was frozen. Hopefully that will change in the future, but we're we're here just trying to tell you what the state of things are right now.
Prohibition on starting any new research on the NIH campus. Pause on recruiting patients for clinical studies. And I'm here to tell you that clinical studies can be very longitudinal
They
and
have to
very,
be.
very time based. And if you're taking a time point from the patients you have, or you needed to enroll new patients at a certain time and you don't, I
Mm-hmm.
mean, it's garbage now.
Yeah, I
It's
mean,
not like
yeah.
you can really.
Or it might set well, and if you miss that, like it can set you back for several months
Yeah.
because like and sometimes like enrollments on these clinical studies are really difficult. Like some people are studying diseases that are relatively rare, or patients aren't just flooding the hospital that have acute myeloid leukemia, for instance. Like you have to find a patient that is in the right age range, is at the right severity of disease, and have to check all these boxes. And if suddenly you find some patients and then somebody tells you, oh, you can't enroll those patients, that's a big hit, because that might have been the first patient that walked in your door in the last month that was agreeing to be in your study.
If everything's frozen and you can't take their blood and you can't look at the cells within, and you just gave them a drug, and now you're
Yeah,
X days out from giving the drug, and this is an important like proof of what's going on
I see. Yeah.
in your field. I mean, that's also just, you
Yeah,
can't go
yeah.
back to when they weren't treated.
Right.
you
Yeah.
can't you can't reverse
Yeah.
that.
If the plan
I
was
know, because I did mice and it's
Mhm.
analogous. You know what I mean? Like that cohort of mice would be kind of like, well, you can't untreat them. They're treated.
Yeah. Now we treated and we missed the data point, so now we
Mm.
can't even use their data. Yeah. I mean, that's a great point.
Beep, 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 beep.
Momo needs science too.
He says, "Fuck you guys."
We're not blinking.
Not blinking.
Not blinking.
This shit better work.
Yeah.
Sorry. Give me a second. No, we can keep
Okay,
going
just let it go.
because
All
we
right.
can we can
All
cut
right.
it. But I had to burp,
Okay.
so it was happening.
All right.
Okay. So while we're talking about clinical trials, let's say you're doing a trial for a drug for a very aggressive
I
cancer,
think you should
stage
stop.
4. Why?
Because you said, while we're talking about clinical trials, were we talking about clinical trials?
I think we were at the end, weren't we?
Oh, I think you said it, or just say on the topic of clinical trials.
Fine, whatever.
Okay, I just want to get to the end of the clip.
Okay, on the topic of.
Okay, stop. Okay,
So on the topic of clinical trials, let's say that there's a trial that's studying a new promising cancer drug for a very aggressive stage 4 lung cancer or glioblastoma, so a brain cancer, where these patients may only have 12 months to live. The way the trial is designed is to demonstrate the drug's efficacy by not just tracking survival, but also measuring things like tumor shrinkage and evaluating their symptoms at very specific intervals. These are predetermined before you begin the trial, which can cost millions of dollars. And if these specific points and the endpoints, you don't manage to gather the data at those times, it's going to basically destroy the infrastructure of the trial so that you can't statistically prove that your drug works. And that can cause the FDA and other regulatory bodies to just reject it.
Yeah, so if you have a gap in your data and you said, look, we're gonna prove this data's or prove this drug's efficacy using this specific data regimen, right, and collect on this certain amount of patients, and then suddenly you have a stoppage of that and you can't collect a data point, or a patient drops out because you had a freeze and everybody had to stop what they're doing, then that could actually compromise the entirety of the data set to the point where the trial would be thrown out and maybe have to be redone.
Because the FDA and regulatory agencies, before they're going to put a drug into the market, it's very stringent what you have to prove,
Yeah.
statistically speaking, about its efficacy and safety.
Hmm.
If you're missing certain points, you're gonna lack the statistical power to meet that barrier of proof.
Yeah.
So there's ongoing trials right now for lupus, like CAR T therapy for lupus, rheumatoid arthritis, glioblastoma, as I mentioned, autoimmune hemolytic anemia, ovarian cancer, cervical cancer, different sorts of leukemias, et cetera, and so forth. And we're already hearing stories of people being dropped from trials
Yeah.
and trials being canceled as a result of this freeze.
Hmm.
And that is just unacceptable. You know, these are people that are very sick, often with terminal illnesses, and this is their only hope and their family's only hope that's being basically destroyed for political reasons.
Hmm.
We have what, like 19-year-olds deciding to
Yeah, to
send
cover, yeah.
emails to the doctors and scientists that are putting on these trials, because medical doctors will go into the clinic and collect those samples, and then scientists will, for example, take that blood or take that tumor biopsy, grind it down into a single cell suspension, stain it
Hmm.
with antibodies,
Right.
do
It's
all
a whole
sorts of
thing.
other analysis where
Hmm.
you take the data in those very
Yeah.
predefined points.
Yeah.
And then a 19-year-old who goes by Big Balls sends you an email that you're fired. You know, that's like really problematic. It's really, honestly, like really sad.
Right, right. Because it's not only the people in the trial. Like, I think this is an important point that, these are. Well, I mean, there are the people in the trial, and they are real people, real patients, like people that you have to get to come into the clinic, and they've got a lot going on in their lives, right? Like, I mean, their illness may be one of the biggest things, but to add more stress to that by having to call them up and say, "Oh, like we can't see you for your appointment today, or we can't collect this data, or you've been dropped from the trial," like that's a huge stressor, and you may not get those patients back or those people that are in your trial back. And then on top of that, you also have the fact that, like, I think what Livy was alluding to is that some people are just getting fired, like, so there's not going to be personnel to be able to continue the trial. So whether it's the patients that got disrupted by this freeze, or having people that were working on the trial collecting data or doing whatever, I mean, it takes a village to get this done, so that we have, and that's why we have the state of the art medicines in this country that we do today, is because of all of that working in concert. And when you put a freeze on it like that and causes disruption, it can have a lasting impact.
It's also important to state that we scientists are not just like, you can't just trade one out for another. If you are taking over a project like that, like a trial, like let's say biopsies of someone's tumor that you're doing
Mm-hmm.
certain immuno analyses on, for
Mm-hmm.
example, no matter how established you are as a scientist, I mean, it could take like a new postdoc like a year to get a handle on a
Yeah, to
project,
get up to speed
to
on the
get up to
very,
speed.
yeah, these are very, yeah, we're all very capable scientists, but like the nitty gritty and the specifics of of a particular scientific endeavor or clinical trial or a drug or a protocol for, yeah, whether that's in the lab at the bench or a protocol for a clinical trial, everything is very detailed and very exact on how you handle samples when they come in, how you process them, what data you get out of it, and all of that is, yeah, it takes a lot of people in
A lot
concert
of
work.
training,
Yeah, and a lot of
and it has
training.
to be perfect. You can't go to
Yeah,
the
or it
FDA and be
fails.
like, oh, well, I didn't really know what I was doing with those mouse lymph nodes,
Yeah,
so on
yeah,
this day they all died.
yeah,
You
and
just
it's highly
lose. You know, your drug loses. It's been decades of work,
mm-hmm,
possibly since this small molecule or
mm-hmm,
antibody or whatever was
yeah,
discovered, and you're in like the final
mm-hmm,
human trials to try to get this into the clinic to try
mm-hmm,
to help people, and it could be
yeah.
just
And
catastrophic.
like for bigger drug companies, like, maybe, this is problematic, but like maybe they get through it. But I mean, for some of these startup companies, they don't just have extra funds to do it again. I mean, we could see actually like the loss of drugs that were in pipelines that failed clinical trials. And because there's not just enough money to do it again, then they might be out of the running. And that could have been the drug that saved your mother or saved your grandmother.
And those companies can apply for NIH grants,
Yeah, those
is
companies can
the
apply for
important.
NIH grants
Yeah,
too. Yeah,
they're
absolutely.
often funded
Yeah,
by
in
NIH
part. Yeah,
grants.
at least in part. Yeah, I mean they'll have.
And there's private like funding sources as
Yeah, they'll have
well.
private funding sources too. But like, yeah, if they had NIH funding, then that could put a halt on the whole thing. Or they're in partnerships. I think a lot of times they're in partnerships with academic institutions or with NIH, with the companies. So
So my hope here with this entire like first episode of this podcast is we have sort of drilled home that the situation is dire, that science moves very quickly, that we will quickly fall behind, We will lose the ability to continue to be leaders in scientific research,
Mm-hmm.
which allows us to have a higher quality of life and a longer life expectancy.
Yeah.
Helps people not suffer.
Yeah, people would have access to just basic medical care.
And I don't think under any circumstances would my colleague here and I ever imply that they're like any other system created by human beings, institution, that there isn't some level of inefficiency.
Oh, absolutely. Yeah.
There will always be.
Mm-hmm.
So that is certainly not what we're ever trying. There will always be some level of corruption. People
Yeah.
are people. Like, let's be real.
Yeah.
We've both suffered in not ideal situations in academia, but I can tell you from my 10 years of academic research that on average, I saw excellence.
Yeah.
I saw people that were really passionate about helping.
Yeah, people that actually care about like that's the prize, right? Like being able to contribute to that body of knowledge that actually helps a person get better, to actually, maybe extend their life or have a better quality of life. Like that's why we're all here and that's why we do it. And we want people to understand that like Livy said, like there's inefficiencies, and I'm sure I would have loved to see some of those inefficiencies addressed, but the very like brash, like reckless way that this has been gone about is going to have a lasting impact and for I don't know how long.
And the only real way to have these inefficiencies addressed is already in place, which is peer review.
Yeah, I mean, a lot of
Because
them
these
are.
projects are so complex that even if we sat and listened to this other lab's talk that's like tangentially related to immunology, but it's a different disease.
Yeah.
They use a different model, it would take us months to get to the point where we could pinpoint exactly what was wrong, if there were minor things wrong with their experimental design or the way that they're doing their stats or like data collection. However, the people that are assigned their paper
grant
or their grant are in that exact field.
Yeah.
And they do catch things. And people do catch things that are published as well if you're silly enough to be actually truly just like put in the same blot in two places or just being wrong.
And that's happened before, but they get caught.
It would take time for anyone to come on the outside. You have to pay thousands of PhD scientists, and their job would just be to study other people's projects.
Yeah,
for long periods of time. It's not feasible, basically.
And in no world is Elon Musk
and big balls
qualified to decide what science is good science, what science is bad science, what's inefficient and what's not efficient, because they're not fucking scientists.
And we will go into this a lot more with the next episode. We really want to talk about indirect costs. So we're going to go into that, but also the NSF terms that they banned or are being flagged, and like now they're paying people to review grants and papers that contain certain terms that are not only like, if you're against like bigotry and you want to be able to like study women, but they're just scientifically invalid.
Yeah. So we're gonna
words like systemic and things like that. Like, and we're just really going to go into that in depth. Why this is such a clear indication that people that have not even the most baseline knowledge of science are making these decisions, and how dangerous that is.
Yeah, and so so we're gonna put together another episode after this one and go more in depth to the indirect costs and those words. You would be shocked to see some of the words on there. I think, if we had any kind of teaser, the words include things like women and black
bias, like a statistical bias, for example.
Yeah, so not only are these
advocacy, advocating to get a certain drug to a certain group of patients that have a disease. These are basic science terms on top of like there being sex-related differences and disease incidents. We're going to go into all this in depth from a scientific perspective.
But for right now, we want to thank you guys for tuning in, and we hope that that we've been informative at least, and that you came out of listening to this like a little bit more knowledgeable about like our field and the field of science and how clinical trials are run and how the NIH works. And hopefully we reach some people today to feel a little bit more knowledgeable about that.
If you have any constructive feedback, anything that you think is incorrect or you'd like to add to, or you'd like to hear more about, please, we'd love to hear from you.
Yes.
We're always open to that.
We're not, we may have misspoke or said something, but
As I said, we're
please,
working full time. We're just
yeah.
doing this because we feel driven to do so. But
Yeah, we would be
it won't
happy
be
to address
perfect. We're just
everything.
yeah,
Yeah,
exactly.
exactly.
So thank you so much, and we'll see you next time.
Thank you guys. Thanks for tuning in. Going. Do we need to take another?
Well, it's going.
Yeah.
This is the old one, but whatever.
Mm.
We just recorded a bunch of shit and then it didn't record. I guess welcome to the life.
All right.